Welcome students. So let's start the fourth module of our course EC305 microprocessors and microcontrollers. So in this module we will be covering regarding the addressing modes that is supported by the 8051 microcontroller, and we'll be looking into the instruction set of 8051 microcontroller in detail, followed by several assembly language programs which has been developed for 8051 execution using the internal registers. So as we know, addressing mode is nothing but it's the method of specifying the data that an instruction has to support, or it can be defined as the method of specifying the data that the instruction has to operate, so that on execution of the given instruction a particular objective has been implemented using the given 8051 or any other microcontroller. So as we looked into the case of the microprocessors also, here this 8051 microcontroller also supports 6 different addressing modes, which starts from register addressing mode, followed by immediate addressing, direct addressing, register indirect addressing, and implied addressing. And the last one, which is the index addressing mode, is basically the mode that is been accepted, or the configuration of the instruction that is been accepted by the 8051 microcontroller when it needs to access some data or address or some instruction from the externally interfaced memory chip. Looking into the first mode of addressing, that is register addressing mode, as we know from the name itself, in this the operands will be available in the registers. So in this addressing mode, both the source and destination operands or the locations will be registers, and in this case we can either make use of register A, B, or any registers named denoted as R0 to R7 from the register bank. And the another peculiarity is that in case of 8051 microcontroller, it is mostly preferred that the destination operand can be should be the accumulator register. Okay, so in this register mode, even though if you look to the uh, general structure, you can see there is an opcode, which opcode means it's a mnemonic which corresponds to what type of instruction is it, and the destination operand supports A, comma B, comma R0 to R7. Similar, in the similar fashion, the source operand is also supporting. Okay, so the fact is that in this there's a limitation. Even though we write this in the general manner, there is a limitation that both the destination operand as well as the source operand cannot be scratch pad registers, that is this R0 to R7. That is, I cannot write an opcode followed by R0 comma R0. Okay, that means in this case, or R0 comma R1. So in this case, both the operands, that is the destination register and the source register, are the scratch pad registers. It is mandatory that in all the operations that is been in all the instruction that is been done by 8051, one of the registers should be always the accumulator. Okay, so you can have some instructions like opcode A comma B, or A comma R0, or B comma R0, like that. Okay, even B comma R0 is supportive, but we won't be using that generally. We will be always using as with one operand stored in the accumulator register. Okay, and in some of the textbooks you can see that it is written that the opcode, let us take an example of in register addressing mode, that the move instruction that is supported by 8051 follows the register addressing mode. So in that case I cannot write move R0 comma R7. Even though it is said in some of the textbooks, it is not supported by the compilers that is currently used by the for 8051 development. Okay, the next addressing mode is the immediate addressing mode, where in this mode of addressing you can see that the source data is specified directly in the instruction itself. Okay, that is the source, and the destination operand can be any register, that is it can be register A, register B, or register R0 to R7 of the register banks being used, or it can be even the internal RAM address. We have seen the, if you need to address the or use the register R0, you can use the address 00H, which is the internal address of the internal RAM. Okay, so even that RAM address is supported. Or apart from all these general registers, even you can specify a special function register like T0, TL0, TH0, etc. So these are special function registers. So any of the registers that it can be the destination operand, but the source operand will be always the immediate data or the data specified directly. And to indicate that it is an immediate data, we use the symbol hash before the value. Okay, so along with the data, if I'm writing 06 hash 06 without any uh, presence, or without the presence of any h or 0x06, in that case you can the compiler takes that 06 in the decimal format and it will be converted into the hexadecimal format and stored to the destination operand or the register. Okay, so when we need to provide a hexadecimal value, either we need to use the prefix 0x before the 2 digit 2 bit value, 2 byte, not the 2 byte, before the 8 bit value, or you need to use the postfix h after the 1 byte value. Okay, so here you can see in the source operand there is an option for either an 8-bit data or a 16-bit data. This is because in case of the SFR we have a special function register, that is DPTR, that is data pointer register. Okay, so which is an 16-bit register actually. So if I need to pass a 16-bit value, that is a 2 byte value, directly to the DPTR, I can use the opcode move. Okay, so the instruction is move, so move uh, dptr comma hash 0100h. That means a 16-bit data is now copied or transferred to the special function register dptr. Okay, so there are a lot of examples, so here we won't be explaining, or we won't be stating some examples for each of the addressing modes. We can see that a same instruction that is been supported by 8051 itself. Okay, 8051, the same instruction itself can be used in different addressing modes when we discuss the instruction set in detail. Okay, next we have the direct addressing mode. So in direct addressing mode, the destination and the source operand can be the internal RAM address locations. Okay, that is both the destination operand as well as the source operand can be RAM addresses, or it can be, one can be register and other can be the RAM address. Okay, so as I told earlier, it is mostly preferred that both these operands can be addresses, or one of them can be register and other one can be the source. That is, destination can be a register and source can be a, um, internal RAM address, or in the vice versa manner, that this destination operand can be an internal RAM address and the source operand can be a register. Okay, but it is preferred generally that the destination operand will be mostly the accumulator and the source operand will be in the format of a direct register address of the internal RAM location. Okay, then we have the register indirect addressing mode. As we saw, here you will be making use of a register itself, but instead of taking the content of the 8-bit content in the register as the data to be operated or data to be read and operated, instead of that, the content of this register will be an address of the RAM location. So if I have a register and I am storing the value 40h in that particular register, that is 8-bit value, it is corresponding the 1 byte value that is available in the register is 40h. Okay, 40, then it is not treated as a data. Instead, the processor will be going to the internal RAM location addressed by 40h, and it will be looking for the data in that location, and whatever data is present there, it will be read and it will be taken and processed. Okay, so here you can see that the register is acting as a source to direct the compiler to the required internal RAM location. So we call this particular mode of addressing as register indirect addressing mode. Okay, and in case of 8051 we do have another one more limitation is that in order to store this address information of the internal RAM, we cannot make use of any of the registers that is available to the programmer. Only the two registers R0 and R1 of the register banks can be used as pointers. Okay, can be used as the registers to point to this particular internal RAM location. Okay, so if I'm using any other registers to store the address value, and if I'm using that register in the register indirect addressing mode, your compiler will be throwing out a error. Okay, that is, you can only use the R0 and R1 registers of the register bank. Okay, so here as we discussed earlier also, either the destination can be pointed using this registers R0 and R1, or the source can be done. So when the point, we cannot use the pointing registers at both the destination as the destination operand and both the source operand is not supported. Any one can be used. So if I'm using the pointer registers in the destination operand, that is R0 or R1, then I can use any of the registers or the RAM address or the SFR registers, SFR register names in the source, or in the vice versa manner, where in the destination operand you will be making use of several registers, and in the source operand you will be making use of the pointer registers. Okay, so in order to indicate that the currently R0 or R1 is used as the pointer register, you will be prefixing that register name with the symbol @ Okay, so @R0 or @R1. So the symbol @ is prefixed with the R0 or R1 to indicate that now the registers R0 and R1 stores a address of the internal RAM. Okay, and the instruction is now in the register indirect addressing mode. Now we move on to the fifth type of addressing mode that is supported by 8051 microcontroller, that is implied addressing mode, where the instruction itself specifies the register to work, and here there is only one register which will be acting as both the source as well as the destination operand. Okay, and as we told earlier, in case of 8051 it is mandatory, or it is designed such that the in all the instructions that is supported by 8051 microcontroller, we need the register A or the accumulator register as one of the operand. So since in this addressing mode there is no multiple operands available, there is only one register in which you can store the operand. Here all the instructions that is supported under the implied addressing mode will be using register A as the source as well as the destination operand. Okay, so the general format is that will be having an opcode followed by the name of the register, that is register A. Now we have the sixth addressing mode that is supported by 8051, which will be rarely used as a beginner. Okay, this is because in case of academic projects or academic days, we will be doing our will be designing some projects such that it will be limited to the or we are nowadays we are making use of 8051 commonly for getting familiarized with the microcontroller. Okay, so in that case we will be mostly making use of the internal ROM available, but when you go for real applications, suppose we need to design an embedded system and implement it using the by using a microcontroller, that is 8051 itself. In that cases, sometimes this 4 KB or 8 KB internal ROM may not be sufficient. Okay, so in that case we may be forced to interface an external ROM. So once you are storing some data into this external ROM, we need to access it. So in order to enable that access of data that is stored in the external ROM, we make use of this addressing mode, that is index addressing mode. Okay, so here the external ROM's memory location from which the data has to be fetched is generated by adding the base address that is available in the DPTR and the offset address which is available in the accumulator register. Okay, so the effective address of the external ROM memory chip has been generated, and the data can be read and copied to the internal accumulator register. Okay, so in order to enable this accessing of data from this ROM, we from the definition we can see that the offset address should be available in the accumulator register and the base address should be available in the DPTR. So these two steps should be initially done. So here you can see an example. Initially I will be clearing the accumulator with a 0, or you can initially load the accumulator register with the necessary offset address value. Then in the second step you can load the base value of the ROM, external ROM, to the DPTR. Okay, then you need to add these two. Okay, so A plus DPTR means you are adding the base address with the offset value and the address location which is pointed by this resultant. Okay, should be accessed and it should be read and copied to the accumulator. Okay, so here we can see you are using the @ symbol. So when I'm using the @ symbol, the compiler gets information that now the resultant obtained by performing A plus DPTR, okay, is an address location. So the compiler should go to that particular address location and it will be fetching that particular data which is available in that location, and it will be copied to the accumulator register. Okay, so in this case you can see this is opcodes. Okay, so there are three instructions here. So these two are move opcodes and this is move C. So move C is the mnemonic which is used by 8051 to indicate that now the controller or the processor in 8051 microcontroller is accessing an external ROM location. Okay, so this is the only instruction, that is move C is the only mnemonic which can be used to access the external ROM locations or any other external memory. Okay, so that was about the different addressing modes that is supported by the 8051 microcontroller. Now let's look into the instruction format and the different types of instructions that is being supported by 8051 microcontroller. Okay, so as we saw in case of 80862, the internal address bus of 8051. Okay, so the internal address bus of the 8051 is 8-bit width. So the maximum size of the opcode that can be supported by 8051 is also 1 byte or 8 bits. Okay, and if you can see here from the slide that the opcode size of all the 8051 instructions are 1 byte, that is 8 bits. So that so this limitation on the size of the opcode is based on the internal bus width, that is 8-bit is the internal bus width of the 8051 microcontroller. So based on that you can have maximum number of instructions, that is which is given by 2 raised to 8, that is 256. Okay, so in this in our 8051 we have 49 basic instructions which can be expanded so that the entire 256 instructions are being realized or can be utilized. 256 combinations are utilized here. Okay, and you can also see that the size of the 8051 instructions can be 1 byte, 2 byte, or even 3 bytes. Okay, so the if you look into the instruction set of 8051, you can see that the number of basic instructions has been reduced compared to that of the 8085. Okay, it has been reduced, but that is you are having lesser number of instructions, but based on each of the instruction can go to different addressing modes also, which will be more clear once we discuss the detailed instruction set. Okay, so based on these features, that is and same instruction is supported by different addressing in different addressing mode, as well as we have lesser number of registers. We have seen that we do only have the accumulator register and the B register or one of the R0 registers. Okay, so in common, if you look to the entire system at a particular time, you can only have um, A, B, and R0 to R7. You cannot use the entire register bank at an instant of time. You can only use one of the register bank at a time. So in one of the register we do only have 8 registers plus 2 another general purpose registers, that is the register A and register B. So 8 plus 2 10 registers. Okay, so with this combination the these are some of the features, or these combinations are some of the features that is supported by the CISC instruction set architecture. Okay, so our 8051 follows the CISC instruction architecture. Now if you look to the general format of the assembly language instruction, the first one, label, which is you can use any combination of uh, uh, letters you decide, so which has to be terminated by this colon. Okay, so apart from any of the uh, words used in the opcode, used as opcodes, you can make use of the in the label, but it should be indicated that the compiler should get information that this sequence of words corresponds to a label is indicated by the presence of this colon. Okay, similarly you can have comments for each of the instructions. So if you have a particular instruction in your program, and another person who is going to check to your program, or is going to interfere in the program that you have developed, okay, needs to identify that this instruction will be performing this particular task. Okay, so for that you can add some comments. So when you are adding these comments, you can indicate the compiler, or the only way to indicate the compiler that from this point the comments will be started is by the presence of the prefix semicolon. Okay, so this is the general format of the assembly language program. So this label side and the comment side is not mandatory for the program, but the instruction is mandatory. Okay, so as you can see, if the instruction is a 1 byte instruction, you will be only having the opcode, then the operand will be the accumulator register. And if there is a 2 byte instruction, one will be the opcode, another one will be the other byte will be corresponding to the operand. And in case of a 3 byte instruction, you will be having 1 byte reserved for the opcode, and the remaining 2 bytes will be corresponding to the operands. Okay, so if you look to the function group, as we have seen for 8085 in our course, here 8051 instructions can be grouped into several functions, and based on that we can have basically five function groups. Okay, starting from the data transfer instructions, followed by arithmetic instructions, logical instructions, bit oriented or manipulation, bit manipulation or boolean instructions, and branching instructions. In several textbooks you can see that we do have classifications up to 7. That is, in branching constructions there are two types of branching. One is the branching to a particular location permanently. The other one is branching instructions, which the branching or transferring of the program execution to a new location is a temporary process, and you will be returning from that location. Okay, so based on those features you can subdivide branching instructions into two. Okay, so that is the difference, or that is some of the variations which has been done by some of the authors for classifying the instructions that is supported by 8051 for improved remembrance. Okay, so if you need to remember all the instructions, if you are having small group with small number of instructions in each of the group, it will be very easy for us to remember. Okay, so here we are just grouping it based on the functional properties, or what are the basic functions that is been done by the various instructions. So we have the 5 basic function groups. The first one is the data transfer instruction, and from the name itself it is very clear that this set of instruction, or this set of instruction, contains the basic instruction that is necessary to copy data between register or external program memory or data memory. Okay, so these are basically the set of instructions that is responsible to move or copy some data from two locations, and this instruction doesn't affect the flag of 8051. Okay, flags that is supported by 8051. And in common the mnemonics used that we see in this particular instructions group are move c, move x. Okay, so this move is used for copying data between internal RAM locations of the registers. Move c between the internal RAM or the accumulator and the external ROM that you are interfaced. Move x is the instruction, a mnemonic used for transferring data from the uh, external data memory, basically external RAM, to the internal register, that is accumulator register. Okay, then we have the mnemonics push and pop, which are used for data transfer between any of the internal RAM registers and the stack memory. Okay, and the stack memory. Then XCH and XCHD are used for exchange of data between the registers. Okay, so internal RAM registers. So in this case, you can see that sometimes the entire data will be replaced or only a small portion of the data is being replaced. Okay. Then we have the second function group corresponds to the arithmetic instructions, and from the name itself we know that this is a set of instruction that is required for performing addition operation or subtraction or multiplication or division, then incrementing the values by 1 or decrementing the values by 1, and the special operation, that is decimal adjust of the accumulator, which is used during BCD or the binary coded decimal operations. Okay, so in this case the mandatory requirement is that whatever be the arithmetic operation that you're performing, okay, the destination operand should be the accumulator register itself. Okay, or it is said that one of the register, even though you can use the source operand to be in the accumulator register, most commonly it is preferred that the accumulator register should be the destination operand, or it should be the place where the resultant will be stored. And in case of multiplication and division, you can only make use of the combination of A and B register. You cannot use A and any other scratchpad registers while performing multiplication or division operation. Okay, so and the another peculiarity of the instructions in this particular group is that after execution of the instruction belonging to this group, the flags will be affected. Okay, the common mnemonics supported or categorized under arithmetic instructions are add C. So add and add C differs in the sense that add C adds the values of the registers or memory locations with the carry flag information, and add doesn't considers the carry flag. Okay, then there is no separate instruction for mnemonic for performing subtraction with and without borrow. There is only single instruction, that is SUBB, and the mnemonic for performing multiplication is mul, and for division it is DIV. And to perform increment by 1 and decrement by 1, we have two mnemonics, INC and DEC. And to perform the decimal adjust accumulator function, we have the mnemonic DA, and in this it follows an implied addressing mode. So as we told earlier, it is mandatory that the operand should be in accumulator register. So the complete instruction for decimal adjust accumulator is DA space A. Okay, now we move on to the logical instructions, which is the group, or this the instructions in this group performs logical operations, various logical operations, and the logical operations supported by 8051 microcontroller are AND, OR, exclusive OR, complement operation, clear operation, rotate, and swapping operation. Okay, the peculiarity of the operations performed in this particular group is that all the operations are performed on bytes of data, but on a bit by bit basis. That is, even though we are going to perform the logical AND between two registers, let us take an example, register A and register R0. Okay, even though we are going to perform logical AND operation on the entire 8 bits stored in the accumulator and the entire 8 bits stored in the R0 register, in effect internally the logical AND operation on these 8 bits are performed on bit by bit. That is, first of all, D0 and D0 will be logically ANDed and the result is been updated. Then D1 and D1. So likewise, bit by bit logical operations are performed and the final result is only affected. Okay, the bit by bit operation is internal. Yeah. Similar to the accumulator register arithmetic instruction set, here also after the completion of the logical instructions, on execution of the logical instruction, the flags are affected. The common mnemonics that is find under that can be grouped under the logical instructions are ANL, logical AND operation, ORL, logical OR, XRL, logical or the exclusive OR operation, CPL complement. Okay, then CLR stands for the clear operation. Then rotate operations RL, RLC, RR, RRC. So RL means rotate left, then RLC means rotate left through carry. Okay, so in RLC, carry flag is also taken into consideration together with the register. RR rotate right, RRC rotate right through carry, and swap is for uh, just swapping the lower and upper nibbles of the register. Okay, we will be looking into the instructions in detail in the forthcoming sessions. Okay. Now going to the fourth group, that is a bit oriented or manipulation or bit manipulation or boolean instructions. So here the instruction will be executed between one bit. Okay, so it may be sometimes on a single bit, or the boolean operations will be between two bits of data. Okay, so basically they are used for setting and clearing some of the bit values. Okay, and apart from that, these instructions under this group can also be used for performing several operations on the bit addressable RAM locations. We have 16-bit bit addressable RAM locations. So if we need to perform some operation on the data that is stored in this bit addressable RAM location, as well as on, we know that some of the special function registers can be accessed bitwise. That is, we have the program status word, which is one of the special function register, but the in this the bits, each of the bits of the program status word can be individually accessed. Okay, so we need to access, if we have some registers like that where each of the bits of the register can be accessed and we need to perform some data manipulation on these bits, we can make use of this instructions in this particular group. Okay, so the mnemonics that is seen commonly under this group are clear, that is for clearing a bit. Set, so there is a small mistake, that is not set B, that is set alone. So clear CLR is used for clearing a bit. So you can see that the same mnemonic clear is appearing on the logical instruction as well as on the boolean instruction, that is in group 3 and group 4. Okay, so how the compiler identifies these two is that if this mnemonic is followed by a register's name like accumulator register, then it is an instruction under group 3, and if this mnemonic CLR clear is followed by a single bit, okay, like carry flag CLRC. Okay, so that is mean there is only a need of clearing the carry flag. So in that case, this instruction is grouped under group 4. Okay, then MOV, again, if the operands to be moved are 8 bits width, then it goes to the data transfer instruction. If the operands to be moved are single bits, then it will be grouped under group 4. Okay, jump if carry and JC and JNC, that is jump if carry and jump if not carry, that is if the carry's flag is set, then we need to jump, and JNC means if the carry flag is not set, we need to jump. So similarly JB, JNB and JBC, so all these jump instructions are performed based on the status of a single bit information. Okay, that is why we are categorizing these jump instructions under this bit oriented or bit manipulation or boolean instruction group. Okay, then we have the logical operations which can be performed on two bits, that is ANL, ORL and CPL. So these are the mnemonics which is common in the logical instructions as well as in the bit orientation. So these instructions, all these mnemonics which you which is been listed under the group 4 depends upon whether it is an instruction supported or for which falls to the group 4 or it falls to any other groups is depending upon the size of the operand that is being used along with each of these mnemonics in the instructions. Okay, now let's continue with the last group, that is the branching instruction group. So basically this group of instructions belongs to the instructions that can be used for controlling the flow of program logic. So the control of flow of program logic means whether this program being executed by the 8051 belongs to the consecutive memory addresses or whether it need to go to some other location to execute some of the operations or we need to insert some delay, etc. Okay, so the another feature of these instructions that belongs to this group is that they have the capability to take some decisions. Okay, to take some decisions on some conditions like whether for example if the register value is 0, then only it should go to this branching operation, etc. So likewise some decisions or actions are taken based on the conditions and the instructions has the capability to make them. Okay, so based on these features, the entire instructions that belongs to this group can be categorized as conditional branching and unconditional branching, which means in conditional branching only if the condition is satisfied the branching action or decision is being taken by the instruction, and in unconditional branching it is independent upon the conditions. So whether the condition is true or false, it doesn't matter. Once the instruction is been seen, then the branching or the temporary transfer of the program execution location will be transferred. Okay, so and the mnemonics that belongs to this particular group are jump, L jump, A jump, S jump, that is jump, long jump, absolute jump and short jump. So these four mnemonics are corresponding to unconditional jump operations. Okay, so the difference between these four jump instructions will be more discussed during the detailed discussion of the instruction set. Okay, then we have JZ, JNZ, CJNE and DJNE, where you can see JZ means jump if 0. Okay, so based upon the condition, only if the value is 0 of the register, then the jumping is been executed. JNZ means only if the register is not 0, has a value which is non-zero, then only the jumping operation is been executed. So the four mnemonics JZ, JNZ, CJ, that is compare and jump if not equal, and DJNZ, that is decrement and jump if non-zero. These are executed. These are the mnemonics corresponding to the instructions which are executed under satisfying some of the given conditions. Then we have the NOP, which doesn't performs any transfer of logic, transfer of the location of the program execution, but it simply inserts a delay in the program. Okay, so this instruction doesn't makes any decision or it doesn't performs any branching, but it is going to introduce an additional delay irrespective of the time that is taken by each of the instructions. So if you have two move instructions, so let us assume that for one move instruction it takes 4 clock cycles to complete the entire execution. So it is expected that after the once the compiler finds the or the compiler finds the first or the when during execution of the program during when the first move instruction is being executed, after 4 clock cycles the next move instruction should be executed. But if you are inserting a NOP, you are going to introduce a delay. So if the default time for executing the NOP instruction is 2 clock cycles, so after the 4 clock cycles the next move instruction was to be executed, but due to the presence of NOP in between the two move instructions, you are going to introduce a 2 clock cycle delay, additional delay between the execution of the second move instruction. Okay, so this is again going to control the time of the program logic execution. So we are calling or categorizing this particular instruction to branching instruction itself. Okay, Then we have the L call and A call, that is long call and absolute call. So these are basically the mnemonics corresponding to calling some specific location for a short interval of time. So the difference between jump and call is that jump makes a permanent uh, branching to a new location. We cannot return from that. But in call, mnemonics, by if you're using L call and A call, it means that you can jump to a new location, and after executing a set of memory location or set of instructions in that, we can return from that. Okay, it is not a permanent jump actually. We can return if needed. Okay, so in order to enable that return from that new location to the old location, we have the mnemonic RET, or the opcode is RET, that is return after a call procedure. And RETI is basically the mnemonic used in the instruction to return from a new location, um, which where this new location was accessed by the compiler, or or the program flow was shifted to this new location due to the presence of an interrupt. Okay, so normally L call and A call is not an may not be, it is not mandatory always, but it may not be the branching or the transfer of the program logic to a new location based on interrupt. But there may be, when you are going to execute the interrupts, you can see that when an interrupt occurs from external or internal source, then it should be treated. So for that, from the current memory location, the processor has to go to a new location, okay, where the solution to solve that interrupt has been written. So it will be going to that particular new location, and it will be servicing that particular interrupt request, and will be coming back to the program and completing the, or it will be resuming with the remaining instructions. Okay, so in that cases, to return from that new location which was accessed by the processor or the controller to service that interrupt request, will be enabled by using this mnemonic RETI at the end of that particular memory space. Okay. So by that we have come to the conclusion on discussions about the various addressing modes and the instruction set in brief that is supported by the 8051. So in the coming sessions we will be having a detailed discussion on each of these functional groups of the instructions that is been supported by 8051 microcontroller. Okay. Thank you.